0.8 grams of acetone is mixed with 12 grams of CHCl3. Okay? Now, at 35 degrees Celsius, the measured vapor pressure of solution is equal to 265 torr. Okay, is this an ideal solution? Is this an ideal solution? In other words, does it actually obey Raoult's law? Well, let's use Raoult's law, calculate what we expect, compare it to what we measured, which is 265 torr, and see if it's lower or higher than that. If it's lower than that, it's negative deviation. If it's higher than that, it's positive deviation. In either case, it's a non-ideal solution. If it's close to 265, in the at 260 to 270 range, it's an ideal solution. Okay, so our ideal is solution equals the mole fraction of acetone. I'll just call it A. Yeah, that's fine. Times the normal vapor pressure of acetone plus the mole fraction of, I'll just do CHCl3, mole fraction of CHCl3. Here we go again, chemistry with all of its symbolism all over the place. Okay, so let's calculate the number of moles of CHCl3. We have 12 grams, and 1 mole of that is actually equal to 119.4, equals 0.1005 mole. And then moles of C3H6O, that's the acetone, we have 5.8 grams times 1 mole, which is 58.1 grams. Okay, and we get 0.0998 mole. Therefore, the mole fraction of acetone is equal to 0.0998 divided by 0.1005 plus 0.0998. You end up with 0.5. And the mole fraction of the CHCl3 is equal to 0.1005 divided by 0.1005 plus 0.0998, and you actually end up with, again, 0.5. So you see the mole fraction of each is 0.5. Now, our P solution is equal to the mole fraction of A, 0.5, times its vapor pressure of the pure solvent at that temperature. For the case of acetone at 35 degrees Celsius, it's 293 torr. That's information that's actually given to you, or you can look it up. Plus 0.5, which is the mole fraction of the CHCl3, and its vapor pressure, 35 degrees Celsius, pure solvent, is 345 torr. That is going to equal 319 torr. So what I would expect under normal circumstances, without accounting for affinity or disaffinity, is 319 torr. Well, what I measured was 293 torr. Clearly, 293 torr is less than 319 torr. So this is negative deviation. Negative deviation means that the acetone and the CHCl3 have some sort of an extra affinity to each other. Well, let's see what that affinity is. As it turns out, it's going to be exactly what you think, hydrogen bonding. This is acetone. This is the H. This extra bonding, the hydrogen bonding, this intermolecular reaction between intermolecular force between the acetone and the CHCl3 causes them to actually stick together more than they normally would. Because they stick together more than they normally would, there's fewer molecules jumping out of solution into the vapor phase. Because there's fewer molecules in the vapor phase, the vapor pressure that I measured is lower than what I expected. That's what's going on. So that's it. Standard Raoult's law. I think the equation is pretty simple, and hopefully you understand what it is that's going on. It's just when you mix things, because now you don't have a pure solvent, you have other particles floating around in solution. They're actually getting in the way of the solvent particles from reaching the surface in order to bust out into the vapor phase. That's all that's going on. If you understand that physically, you'll understand everything else. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.